In this animation, we will illustrate the workflow of our framework. The Carpe ID framework, highlighted in yellow, is encapsulated within our algorithm, COLP read, represented in light blue. The pipeline starts by receiving an input image from an external source, such as a camera. This image is processed through three distinct modules: the instance segmentation network, the feature extractor network, and the image pool collector. Firstly, the instance segmentation network is employed to identify people in the image. These detections are then passed to the feature extractor network. Using both the people detections and the original image, we crop each person's image based on their bounding box, remove the background using the mask, and calculate the feature vectors. These feature vectors are subsequently sent to the re-identification module, which assesses whether any of the features resemble the statistical model acquired up to that point. If the target is re-identified, the model is updated with the new target features. The output of the re-ID module represents the final output of our framework. Once the target data are available, they are passed to the image pool collector, which distinguishes between target and distractor images. This process continues until the image buffer in the pool collector is full or if the target is lost for a predetermined amount of time. In such scenarios, the image pool collector organizes the image buffer into batches for training in the twin network. Once the images are ready, they are passed to the twin network, and the training process begins. We will delve into the details of how image pool collection and training work later. Once the training is complete, the obtained weights are copied into the original network. The training images are also used to update the re-ID module, allowing for a swift alignment between the new network and the statistical model, which was initially paired with the old network weights. In this animation, we delve into the image pool collection and parallel training blocks. Throughout the application, the image collector continuously acquires new target and distractor images. When the training procedures need to start, the image collector processes older target images, and extracts those whose features are the farthest from the statistical model obtained thus far. These selected images are then combined with other images and divided into batches to align with the training setup of the twin network. These image batches are subsequently fed into the twin network, and the training process begins. The network outputs the features extracted from the images, which are utilized to compute a triplet loss. To determine which features belong to the target and which belong to the distractors, a one-hot vector is employed. The triplet loss selects a target image as the reference, known as the anchor, and utilizes this information to compute the Euclidean distance between the features. It aims to minimize the distance between the features of the target and the anchor while maximizing the distances to the distractors. This loss is then used to execute backpropagation and train the network. This entire process is repeated until the image buffer is fully utilized. Upon completion of the training, the newly obtained weights are ready to be copied into the primary network. Thank you for your attention.